Okay, so I'm going to be doing question 54 from chapter 27, and the question says, in the Bohr model of the hydrogen atom, in the lowest energy state, the electron orbits the proton at a speed of 2.2 times 10 to the 6 meters per second, in circular orbit of radius 5.3 times 10 to the negative 11. We're going to be answering these two questions, A, B, and C. A says, what is the orbital period of the electron? B, if the orbiting electron is considered to be a current loop, what is the current? And C, what is the magnetic moment of the atom due to the motion of the electron? So let's do A real quick. Orbital period. So really we just need a distance and a velocity. The distance here, since it's in circular motion, is going to be 2 pi r. And here r is going to be equal to 5.3 times 10 to the negative 11. And velocity is just 2.2 times 10 to the 6th. So here we just plug in the values on this equation. Period equals distance over time, distance over speed. And the meters are on both values are going to cancel out, so we just left with seconds here. And this is how we do the first problem. The second one is going to be what is the current. So we just need a current source, and then we need a period, which are right here. So the current source is just going to be the electron, which is a 1.6 times 10 to the negative 19 coulombs. And period is going to be 1.51 times 10 to the negative 16 seconds. Period we just found on the previous question. So here we just plug in the values in the current formula, which is current equals electron, the value of the electron divided by the period. And here we just plug in the values, and we get a coulombs per second, which is basically amps. And here at the bottom it's just milliamps if you want to convert it. And for the last one, which is magnetic moment, we really just need distance between the electron and the center of the orbit. So here we're going to be using the equation mu equals I times A, which is current times area. Here I is going to be equal to basically what we found before on the previous question right here. And A is going to be just pi r squared, since it's in spherical like movement. Just to see like you're trying to get the values throughout that circular sphere. Anyways, yeah, so you just use this formula. You plug in the values of A and I, and now comes this value right here, which is in units of 8 times meters squared. And that's pretty much it for this question. Sweet.